Assalamu alaikum class. Today we will move forward toward our next topic, that is graphs. Graphs are important data structure because anytime there is set of object and there is some sort of connection or relationship or interaction between pair of objects, a graph is a good way to model these kind of applications. For example, this can be found in computer and communication networks, transportation network, for example, roads. So, what is graph? A graph is a pair of V and E, where V is a set of vertices and E is a set of edges connecting the pair of vertices. For example, a vertex represents an airport and store the three-letter airport code. In this graph, SFO, ORD, and PWD are the airport code, and these are the vertices while an edge represents a flight route between two airports and store the mileage of the route. In this example, the mileage between SFO airport and ORD airport is 1843. According to the edge types, a graph can be directed or undirected. A directed graph is made up of directed edges. A direct edge is an ordered pair of vertices u and v, in which u is the origin and v is the destination. In this example, between ORD and PVD, ORD is the origin and PVD is the destination. While an undirected graph is made up of undirected edge, an unordered pair of vertices. Directed graph In directed graph all the edges are directed, for example root network. In undirected graph all the edges are undirected, for example network. Graph theory has many applications. For example, the concept of graph is used in designing printed circuit board and integrated circuit in electrical engineering field. It has also been used in transportation network, highway network, or flight network. In general, routes between the cities can be represented using graphs. In computer science field, graph theory is used for the study of algorithms, for example, Kruskal algorithm local area network, internet, and web. In database field, ERD is an example of graph. A graph is a diagram of vertices and edges. It has at least one edge joining a set of two vertices. The concept of graph stands up on some basic terminologies such as vertex, edge, degree of vertices, and property of graph. A vertex is a point where multiple edges meet. It is also called a node. A vertex is represented by an alphabet. In this example, U and V are the endpoints or vertices, while an edge is a mathematical term for a line that connects two vertices. Many edges can be formed from a single vertex. Without a vertex, an edge cannot be formed. There must be a starting vertex and ending vertex for an edge. In this graph, vertex u is adjacent to vertex v because there is a direct edge between these two vertices. In a graph, if a pair of vertices is connected by more than one edge, then those edges are called parallel edges. In this graph, x and z are two vertices which are connected by two edges h and I. So it is called as a parallel edge. In a graph, the number of edges coming out of a vertex is called the out degree. Number of edges coming in is the in degree. In an undirected graph, we just talk about the degree of a vertex. It is the number of edges linked with a vertex. In this graph, x has degree 5 because there are 5 edges connected to the vertex x. A path is a sequence of alternating adjacent vertices. It starts with a vertex, it ends with a vertex. There are two types of path, simple path, not simple path. In this example, P1 is a simple path. It starts with vertex V, it ends with vertex Z. V, X and Z. They are all different vertices, so it is a simple path. P2 is not simple path It starts with vertex u and with vertex v, and w is repeating two times. So it is not a simple path. Cycle is like a path, a sequence of adjacent vertices. The only difference is that it starts and ends with the same vertex. There are two type of cycle, simple cycle, not simple cycle. C1 is a simple cycle in this graph. It starts and ends with V, X, Y, W, U, V. All of its vertices are different. While in not so simple cycle, it starts with U and ends with U. U, W, X, Y, W, U. W is repeating, so it is not a simple cycle. How graph differ from trees. We don't need a root node in graph. There's no implicit parent-child relationship. There may be several paths from one vertex to another. Directed graphs are useful in modeling communication network, while undirected graphs are useful when directions are not required. Basic graph operations include construction of graph, check whether it is empty or not, destroy a graph, insert a new vertex, insert a new edge, delete an edge, delete a vertex, traversal, determining the shortest path, determining if node or vertex X is reachable from vertex Y, and so on. For the representation of graph, we will be using two-dimensional arrays that are used to store information that we normally represent in a table. Two-dimensional arrays are like one-dimensional arrays. For example, the application of two-dimensional arrays include a seating plan for a room that is organized by rows and columns, a monthly budget organized by category and month. Let's recall the concept of two-dimensional arrays and the declaration of two-dimensional arrays. A two-dimensional array is a matrix of rows and columns. Think of a table. A two-dimensional arrays have two subscripts. First, you have to specify the data type, then name of the array, and within two square brackets, you have to specify sizes. In this example, max students are rows and max labs are columns. Two-dimensional arrays may also be visualized as one-dimensional array of arrays. 2D array can be initialized by specifying bracketed values for each row. In this example, this is an array with 3 rows and each row has 4 columns. This is row 0, this is row 1 and this is row 2. An element in a two-dimensional array is accessed by using the row index and column index of the array. For example, this statement will take the fourth element from the third row of the array, that is 6.